Good morning, ladies and gentlemen. This is Ben Keyser with Applied Flow Technology. I want to thank you all for joining me this morning on this lovely, fine Thursday, and I look forward to demonstrating the new features of AFT Arrow 7 for you. Lots of new and exciting things are available, and so this will give you a good inside scoop of how to get using with them. So I'm just going to go ahead and get started here. I apologize for being about a minute or two behind. I was doing a quick sound check and just making sure that everything is in order. So let's go ahead and begin. One thing I want to notify everybody is that there's several handouts in this webinar available for you. There's a data sheets for AFT Arrow and the modules. There's a new feature list as well. And I also attached my new features webinar. And so if you're listening in live, you can have access to my webinar presentation immediately. If you are listening later, because this webinar is being recorded, then you'll be able to, if you email me, my email is benkeiser@aft.com. I'll be happy to send you a copy of my presentation. So here's what we have going on. Some newsworthy items. Fathom 10 was released back in mid-May. AFT Arrow 7 was launched in middle of July, and then AFT Impulse 7 is expected to be released late third quarter, early fourth quarter of this year. We're very excited about that. Got a lot of new stuff coming along. And it's really important to make sure that you are up to date with the latest releases, especially when we just come out with a brand new version. We're constantly adding in new features and capabilities as things go forward, and you'll definitely want to make sure that you take advantage of those. Also, you'll be able to get the maintenance releases and stay up to date. And so the latest for Fathom 10 is August 20th. The latest release of Arrow 7 was August 6th. And I believe we'll probably be coming out with another maintenance release here soon. So where do you find AFT Arrow 7? If you go to our website, aft.com, under the downloads menu, you can go to current full version, and you'll find AFT Arrow. And so in there you can do things like you can view the release notes, you can download the full version of the product, and then this area right here is really important because that allows you to sign up to receive notifications of whenever we put out a new maintenance release. So every time that we come out with a new one, you'll be emailed. If you have the privileges of being able to download and install the software yourself, you can. If you don't have installation privileges, you can still download it, but you can also bother your IT guy. That way they can get it installed for you. A few other areas where you can find what the list of new features are is if you go to the AFT Arrow product page under the products menu, you can go in there and find a list of full features, and then this is where you can find the AFT Arrow 7 new features. So those are some areas where you can find that information. The best place of where you can find the new features of AFT Arrow, though, would be in the AFT Arrow help file itself. And so I'll go ahead and open that up for you. If you're not familiar with the installation structure, typically the AFT products are installed on your C drive. And so if you browse to the AFT Arrow 7 folder, you can find arrow.chm. That's your Arrow help file. And then if you go to getting started, what's new in version 7, this contains the full list of all the new features, and it also contains links to the various help topics that will show you how to use those new features as well. So that's where you can find the full list of all the information there. All right, back to this here real quick. I'm going to go over the key new features today. I'm not going to cover every single one of them. I'm only going to go over a few. And so some general new features I'm going to talk about, setting defaults from the startup window, ref prop, talk about some Junction new features. We've redesigned the fan and compressor property window, so you'll get to see what that looks like. We also included a preferred operating and allowable operating range. That way your fans and compressors can be sure that they are operating within a close proximity to the best efficiency point. And that's really important to do. Other things that we have is new relief valve capabilities in Arrow, and I'll show you that. Some primary window new features worth mentioning, the Isometric Grid. That way you can have a much easier time of drawing the model of your system to make it look isometric like you're drawing. So that's a really helpful tool. You can do different colored scenarios. So that way if you color code your scenarios, it'll make it a lot easier to determine if you're in a parent scenario or a child scenario or a grandchild scenario. There's a new symbol that shows if you have lumped in additional fittings and losses to your pipes. The visual report control is a lot user friendlier when you're trying to decide if you want to not show various pieces of information on the visual report. So those are some key general features I'm going to go over. New features for pipes and that I'll be talking about is new heat transfer capabilities. There's a new intermediate pipe elevation option. There's a new some new pipe material standards that are built in. And then we're going to focus the majority of our time today on integration. Integration with Excel primarily, as well as importing various models. And so things that we can import now, piping component files. So if you have a isometric drawing from one of your CAD programs, for example, then you can import that PCF file and it will build the model and the layout of your system for you. Excuse me, I just had to mute myself really quick. We're located right here in Colorado Springs, Colorado in the United States, and it's a beautiful area out here, but we are very high up in altitude. Colorado Springs is about 6,000 feet above sea level, and we have a very dry climate here, and the altitude can really play a major impact on how you feel. And so make sure that if you ever visit Colorado or Colorado Springs especially, got to drink tons and tons of water. And so with it being very dry, I talk a lot during these webinars, and so try to mute myself. I need to clear my throat. So if you all of a sudden hear me drop off, don't panic. I'm just probably muting myself. Wait a few seconds and I'll be back online shortly. Okay. Other things that we can import is Caesar 2 neutral files. So if you've done a pipe stress analysis of your system, you can generate a Caesar 2 neutral file, and that will build the model of your system in AFT Arrow. You can also use EPANet. Now, EPANet is mainly for the water industry, so it's available in Arrow, but it doesn't really apply as much. We can also import or GIS shape files, but that's been in there since Arrow version 6. There's some greatly enhanced Excel integration that I'll be showing you. New Excel import capabilities where you don't have to memorize or always be referencing the help file for codes to import Excel changes to your model. And then we also have the capability to import changes to specific scenarios within the scenario manager. And that's a lot more powerful than it was before, because before you could import massive amounts of changes, but only to one scenario at a time. So now you can do it to multiple ones, and it's a very useful and efficient capability that you'll want to get familiar with. There's a new Excel export manager, which allows you to automatically export your model results into an Excel spreadsheet. And before, you'd be able to easily copy and paste your data, but now there's a lot easier ways to be able to do that, and so you'll see that shortly. Okay, so jumping into things here, this is a couple of basic new features that you can work with, and right when you first start AFT Arrow, you're going to see the startup window right here, and I'm actually going to change my pen color really quick. There we go. And so this is the new area where you can configure some of your modeling preferences before you even start building your model. And so I have AFT Arrow that I just opened. So if you click on modify, you can see where you can change your unit sets, your language preferences, which type of workspace you want to deal with, either the original two-dimensional workspace or the isometric workspace. You can show your grid. You can also pick a default pipe material from the list if you want. So those are some useful modeling preferences that you can start off with before you even get into the software. The next thing is RefProp. So if you go into the System Properties window, there are several fluid modeling options available for you right here. And excuse me, the AFT standard is, it contains very simplified models. They're fairly accurate, but you're going to pick your equation of state and your enthalpy model. If you choose ASME steam tables for water, that gives you more accurate steam data. Also, if you did the ASME steam tables, it knows where the saturation lines are. So if your temperatures drop below the saturation line, Arrow will be able to warn you if you're saturated with the ASME steam tables. ChemPack is another thermophysical property database that's available. It contains accurate thermophysical properties for about 600 different fluids, and the powerful advantage to that is you can create mixtures on a mass or mole fraction basis. And so if I went to ChemPack right here, I can do create new mixture and add, and then this is where I can do my different components on a mass or mole fraction basis. None of those three options are new. They've been there for a long time. ChemPack, you have to purchase an additional license of the ChemPack database to be able to use it with Arrow. So the cool thing about RefProp is from the National Institute of Standards and Technology up in Boulder, Colorado, here in the US. And so they have a very well-trusted and accurate thermophysical property database. And within AFT Arrow, the NIST RefProp database allows you to have access to about 150 to 200 different gases, all with very accurate properties. You have the same capability to create new mixtures just like you do with ChemPack. And the key thing is NIST does not require an additional license. The NIST RefProp database is built right into standard AFT Arrow. So if you don't have the ChemPack database, well, check the NIST RefProp fluids, and if your fluid components are in there, you may not need to get ChemPack. And so that's the new available option for you. All right, so those are some new things. Our fan and compressor window has changed with the look and feel, and so we've made a much clearer distinguishing characteristic between centrifugal compressors, fans, and positive displacement compressors. Now, here's the thing: there's multiple ways to skin the cat. So if you did a fixed flow rate, that can work for compressor sizing or fan sizing or a positive displacement compressor. And then a curve is a curve. So it's really just making it a little bit easier to see what you're doing. If I go in here to AFT Arrow and drop a fan on the workspace, I can click on any of those buttons. So I click on centrifugal compressor. If I'm sizing the fan, you'll just need to put in a fixed flow rate and maybe an efficiency. If you're doing a compressor curve, then you can enter your curve data. The other new feature that is available is after you enter in your efficiency or power curve, you can go to the configuration data tab, and this is where you can enter in your preferred operating range and your allowable operating range. And so that will help you see how close you are to being within your best efficiency point proximity. And so that's a new capability that you could take advantage of on that tab right there. Okay, if you were to do a fan, you have the same options essentially. Fans, you can do either sizing, that's again fixed flow rate, or fan curve. The thing with a fan curve that's different than a centrifugal compressor is for fans, you don't really have to deal very much with the compression thermodynamics. And so that's one of the things that we've done is we've made the interface more simplified so that way, depending on what you're working with, it'll streamline your process. So if you're dealing with a fan, it's not going to complicate everything that you're seeing with all that compression thermodynamics if you don't need it. And last but not least, we've got our positive displacement compressor. This is a fixed flow rate again, but here the compression thermodynamics are important to pay attention to for a PD compressor. So those are some different options available for you. The next thing on the list is the new relief valve junction. And so here's a relief valve, and a few new things about this is we have these profiles that you can work with, which would dictate if your relief valve is opening either instantly or based upon pressure. Instantly, the relief valve is either going to be open or closed, and that's it. But if you choose pressure, it gets to be a bit more sophisticated, because if you choose the pressure profile for an opening and closing relief valve, then you have these new features available down here, where you can do a constant back pressure valve. That's where your downstream pressure is isolated from the upstream pressure on your relief valve. The advantage of using that option, if you have that type of relief valve, is because you can enter what your set pressure, your blowdown pressure, and your overpressure values are on an absolute or a gauge pressure basis. If you were to toggle that option off, then it's based upon a pressure difference that would cause your relief valve to pop open. So those are some new features there, is the ability to specify what your overpressure, your set pressure, and your blowdown pressures are. And it will look just like this graphic right here. So that is helpful to give you a picture of what these values are going to do. So typically you'll have a set pressure. That's the pressure that will cause your relief valve to pop open. And then when you go to the loss model tab, this is where you can specify what your subsonic loss model is in this area over here. So based upon what your loss model is, as well as your values are, that'll dictate where you are on this curve from when your valve first pops open to when it's fully open at the overpressure. And then maybe your relief valve closes at a pressure that's less than your set pressure. So you can account for all that here. Another thing, new thing that you can do is you can do remote sensing. And so for that, if I have a couple of pipes like this, and maybe another pipe right here, and maybe this is a branch junction, here's what you can do is in your relief valve, I'll use the pressure option again. If you turn on remote sensing, this is where you are able to specify your set pressure in reference to a different area of your system. So maybe the relief valve does not pop open based upon the immediate upstream pressure. Maybe your relief valve starts to open based upon some other pressure in this pipe, perhaps. So if you turn on that remote sensing capability, that allows you to pick the location, inlet or outlet, of where your relief valve is sensing the feedback in order for it to pop open. So that's a new capability with Arrow 7. Finally, one other new feature with Arrow 7, let me go back to the instant option right here, is with reference to the loss models themselves. And so the new loss model that's available is this CDA constant. So if you choose the CDA constant option, what that allows you to do is it allows you to pick a API 526 designation for the type of relief valve that you're using. So you can choose any of these, and then that's going to give you what your effective orifice area is, and you put it in your discharge coefficient, maybe that's what it is, and then that'll give you your CDA value. This is really important to do this because you want to have a CDA value to determine if you are sonically choked across your relief valve. And so as you're flowing through there, when you enable those CDA values to be entered, then Arrow will know if you're sonically choked through that type of restriction there. So those are new things for the relief valve junction. Okay, moving right along here. The next thing is our isometric grid. And so the isometric grid has lines that go diagonally and vertically in that sense. And the cool thing is, if you're drawing a pipe from one point to another point, you're going to see this red dotted line appear. That red dotted line is going to give you a visual indication of what that pipe is going to look like once you let go. So if you let go of that pipe, that's how the pipe is going to be laid out. Now let me delete everything off my workspace here, and I'm going to show my grid, and I'm going to go to pipe drawing mode and turn on isometric. Now that I have isometric turned on, here's what happens when you draw that pipe. As you're drawing it from one point to another, you see that red dotted line. If you use the arrow keys on your keyboard or your mouse wheel, you can actually change what that red dotted line is going to look like. That way, it'll make it a lot easier to draw your isometric pipes. So just go from one junction to the next and then use your arrow keys to change how your pipe is going to be laid out. So that's a really nice ability. The next thing is, if you have a system that looks kind of like this, we've got some new junction icons that you can customize like this. That way your elbows and your spray discharge nozzles can all point into the pipes themselves. Now that makes no difference on the results whatsoever, but it's aesthetically pleasing. So, and we're engineers, we like things to look nice. So here's how this looks. Is if I wanted to put a elbow right here, what I can do is I can go back to my normal drawing mode there, and I can grab the elbow, I can hold the shift key down, and I can split that pipe. Well, it's not going to let me do it. But anyway, there's my new elbow. Now I want this elbow to point into the pipe itself. I'm just moving things around a little bit here. This elbow is not actually connected to that pipe, which is fine. So what you would do here is you right click on that junction and then customize the icon. This is how you can change what your pipe connections would be. And so that is the one that looks like what I will need to use. And I can rotate it until it fits in the line. And maybe that's not actually the one. Maybe I need to use this guy. Or maybe it's this one. Well, anyway, you get the idea. So those are new customized icons that are included. And so you'll have to play around with it a little bit to figure out which icon that you're going to need. That way it fits with the way that you've drawn your pipe. So that's the isometric grid. When I talked about background colors, this is what I meant. And so in this particular example, I have several different scenarios. And I've got a base scenario, I've got a grandparent, a child, and then I have a couple of grandchild cases. And so all you would do is go to the Tools menu, and then you would access the User options. And in the User options, go to Colors and Fonts. And this is where you can color code your different scenarios in this fashion right here. And that way, once you color code your scenarios, whenever you go to a different scenario and you load it, it's going to change the background color. That way you'll know exactly what scenario that you're in. So that's a nice thing that you can play around with. All right, new fittings and losses. You've always had the ability to enter additional fittings and losses into the pipes themselves. Now we have a new indicator where we use this ampersand in front of your pipe label that will show you if you have additional fittings and losses in that pipe. So you'll start to see that if you have a lot of Arrow 6 models or other previous version Arrow models that you bring into Arrow 7, if you see all those ampersands popping up throughout your model, this is what that means. You've got additional fittings and losses in those pipes. Now, side note, with regard to AFT Arrow, I'd recommend not using the fittings and losses very often. The reason why is because the location of where a fitting is actually specified in your pipe length, that's going to change the pressure loss across that fitting. So if your fitting is 10 feet into the pipe versus 30 feet into the pipe, your actual pressure loss across that fitting is going to be different. It's not the same like incompressible flow. That's special about compressible flow. So that's one reason why it's recommended that in an Arrow model, try to use junctions more often, because all we're doing with these fittings and losses is we're just calculating what this total K factor is, and we're averaging it out along the whole length of the pipe. So in Fathom, it's just inlet outlet. In Arrow, we actually break the pipe up into bits for every single pipe in the model. And we march down that pipe and we calculate what your pressures and temperatures and velocities and everything else are. So the moral of the story is when we average out this K factor, maybe we've got a K factor of 2 averaged out along each axial point right here in the pipeline. So that's going to change what the actual, if you have a K factor of 2 that's averaged out right here, but your real fitting is, 2.5 or whatever, your results are going to be a bit different. The other thing is if you have fittings like restrictions or area changes that are lumped in, we're not going to do the sonic choking calculations there. So if you are going to have a restriction or a expansion where you can sonically choke, it's important to model those as junctions explicitly. That way we'll tell if you're sonically choked or not. So that's a side note about when you're using this for AFT Arrow. And the general advice is to try to use junctions more often than using the intermediate of the fittings and losses. Okay, so here's the new and improved visual port control, and the main enhancement is right here on the Show Selected Pipes and Junctions tab. So in this model, I have 17 pipes and 18 junctions, and we've color-coded the columns. That way it's much easier to see which column represents the pipe or the junction number, which column represents the name, the piece of data that you want to display, and the graphical pipe or junction itself. So in my particular model here, I have several T's that are in that model where I don't want to display the data. The data could be, pressure loss or K factor, and I don't want to show the data for those items. So what I would do is I would check the boxes for each of those types of junctions to highlight them. And then in the data column right here, I would simply uncheck the box right here to toggle the data for those components off. That way, when I show my visual report, it is not going to show any data for the T's. So the visual report is a little bit easier to see what you're doing now with that color coding. Excuse me, just had to re-highlight or rehydrate there really quick. All right. Some other piping new features. There are new pipe materials that are available to you. And so if you go under the pipe material drop-down menu, you can see that we have these DIN and EN standards. So those are some new pipes that you can work with. Now, if there's a pipe material that you need to model that is not in the software, don't worry about that. It's very easy to customize your own pipe material database. Now, that is outside the scope of this webinar, but let me take another sidestep to our website really quick and show you where you can find some incredibly useful resources. If you go to our website, aft.com, under the Learning Center, you can find our tips and tricks blog page. And so under tips and tricks here, this is where you can find several blog articles that we've written on how to use the software more efficiently and effectively. And if you go back a few pages, I wrote a 4-part blog series all on how to use databases. And so it's probably on page 3, perhaps. Let's see here. It's somewhere in there. It might be page 5. Anyway, be sure to peruse. I mean, as you can see, we've got tons of articles in here, and even articles that we wrote 3 years ago, they're still relevant today. So if you want to learn about how to build your own pipe material databases, go through our tips and tricks blog page, find the articles I wrote, and it'll show you how, or email me, and I'll send you a link later on. All right, back to Arrow. Let's see. Okay, so the next new feature is included in the Use Intermediate Pipe Elevation option. Now, the Use Intermediate Pipe Elevation is on the optional tab of your pipe property window, and you've always had the ability to include intermediate pipe elevations, but the new feature is now you can do a point-to-point option. Let me open up a model really quick that shows what I'm talking about. And so what I'm going to do right now is I've got a model that I built in Fathom. I'm going to show you how to import a Fathom model into Arrow. So if you know one of our AFT products, you know how to use the others, and you can import AFT models into the different AFT software products that we offer. So all you would need to do is go to File and then Open, and then browse to where your Fathom model is located. And so for me, the model is in here. Now, as you can see here, the default file type that's going to pick is AFT Arrow. I have to click on that drop-down menu and change it to look for all models. Now, I can import a Fathom model. The one I want to open is this guy right here. So while that is opening, I'm also going to open up a spreadsheet that I have. There we go. Perfect. Okay, so here is my new AFT Arrow model that I just brought in from Fathom. Really cool, very powerful capability. So in order to capture the elevation change throughout your pipeline and your piping network, is you have to specify a elevation at junctions. Okay, so that's one of the common pieces of data that you need for any of these junctions, is that all your junctions have to have elevation data specified in them. So if you want to capture your elevation changes, that's what you have to do. And as you can see, I have 10 intermediate elevation points, not including the inlet and the outlet. So I've got 10 intermediate points there. There's a much, much easier way to do this, okay? So if I scroll over, here's that same exact system, but in this case, I'm only using one pipe, okay? I came up with a arbitrary grid scaling that I made up on the spot, and well, in the Fathom model is about 1,017 feet. So something changed here that didn't get brought over, and I'm not sure what it was. But anyway, you've got your total length of the whole pipe itself. If you go to the optional tab, well, that's embarrassing. I thought that the intermediate pipe elevation option was available for AFT Arrow, and apparently it's not. So that's only something that you can do with Fathom. So the intermediate pipe elevation Can't do that in Arrow, so forget what I said there. All right, moving right along, let's talk about heat transfer. Okay, so if I want to model heat transfer, you just draw a pipe on the workspace. You can do heat transfer through pipes, heat exchangers, etc., fans and compressors. You got to specify a diameter. So if you go to the heat transfer tab, we've had convective heat transfer for a long time, but if you select convective, for the external heat transfer coefficient, the old way is that you would have to specify what your external heat transfer coefficient is directly. Okay. Now we have the correlations built in. That way, if you choose correlation, you can specify whether or not it's forced convection or free convection. And then you would define what your ambient temperature is and your fluid velocity, which is essentially your wind speed. And that way, your external heat transfer coefficient will be calculated for you. And as your surface temperatures change down your pipeline, your external heat transfer coefficients would also change. So this will capture that automatically for you. That way you don't have to specify it manually anymore. A couple other new features with heat transfer. There's a new buried pipe thermal model. So in this case, you would specify your soil surface temperature, your buried pipe depth, and then your thermal conductivity of the soil itself. So that's easy enough. And then the last new feature for heat transfer on pipes is this convective heat transfer with heat tracing. So if you have tubes wrapped around your pipes to keep it warm, you can enter your heat tracing as a constant heat flux. And so those are new heat transfer capabilities for Arrow 7. All right. Now we're getting into the fun stuff. We're talking about integration with Excel and other CAD programs. So I'm going to start with talking about importing from Excel first, and then I'll go into talking about how to export from the model into Excel using the Excel Export Manager, and then I'll show you how to import models, or import neutral files to build the layout of your system. So Excel integration. For importing Excel changes, there's a new AFT Arrow Excel import workbook that is located within the AFT Arrow 7 application folder. The important thing is to copy that file and paste it somewhere else on your computer. Don't ever open that file from that location, because the problem is if you change it in this folder, then you change it for good. And if you want to have the blank file that we gave again, then you're going to have to uninstall Arrow, delete the Arrow 7 folder, and then completely reinstall everything. So you don't want to do that. Just copy it and paste it somewhere else. Now, the Excel import changes has been around for a long time in Arrow, but the new thing is you don't have to go to the help file and look up what a change code is anymore. So let's say that you want to import changes for pipe lengths. You don't have to go into the help file and figure out that the pipe length code is maybe 1301. And then let's say you want to import valve CV changes. You'd have to go into the help file and figure out that your valve CV is, maybe parameter number 500. You don't have to do that anymore. And so, let's see. Give me 1 second here. I was trying to close an Excel spreadsheet and I had to say I didn't want to save it first. Okay. So here's the AFT Arrow 7 application folder, and here is the blank Excel workbook. This is what it looks like once I get it open here. Hang on 1 second. Okay, let me try this again. It's opening up in my other monitor, and I'll bring that over here and momentarily. There we go. Okay, so here's what this looks like. The workbook contains examples. Okay, that's all these are. These are examples. You don't have to keep that information in there. They're just to highlight what you can do. And so these instructions are important to pay attention to. So make sure you read those. That way you'll use the Excel spreadsheet appropriately. So what you would do is the object number, that is the pipe or junction label in your model. So pipe number 1, 2, 3, etc. So the first thing is you would go to the object type, and for the drop-down menu, you would choose whether it's a pipe. And if it's a pipe, then you need to put in your pipe number. So maybe it's 5. After that, you would pick a parameter. So maybe you want to put in a fixed loss factor to that pipe. Then your change code is going to be to either set that set your value to an exact value in column G, or you can do it by changes as well. So maybe you want to not specify an exact value, but maybe you've already got data in your model and you want to increase data either by an exact value. So if your K factor is 10 and you want to make it be 15, then you would say +5. Or you can change it by percent. So if you want to put 10% in there, you can do a change by percentage in that case. If you did a junction, you can choose compressor or fan. These are the compressor or fan parameters that you can change. Maybe you want to change the speed percentage, and then whether it's set equal to value, yada, yada, yada. And so that's a very useful new feature is the drop-down menus. That way you don't have to know what the codes are from the help menu for parameters, object types, or change codes. Next is the scenario path name. Okay, as I mentioned before, in previous versions, you would only be able to import these changes into one scenario at a time. All right. Now you can import changes to different scenarios all at once. So what you would do is you would set up all of your various changes, and then you would tell which scenario path that change is going to go to, and that way it imports everything accordingly. So let me close this spreadsheet here, and I'm going to open up the one that I already created again. And so let me go to my folder there for that. And let's see. So we go back. Then let me open the model. All right. Beautiful. Okay, so what I did was this model that I created comes from one of our examples, and then I made it more complicated. So if you don't know where to find all of our walkthrough tutorials, go to the help menu, and then show examples, and pick your favorite units. And the one that I modified was the compressed air system. So basically, I just took this system and I put in a heat exchanger into each of these pipes right here. And after I put in the heat exchangers, I duplicated that system several times, and now I have this. Okay, so in my base scenario, as you can see, I don't have any piping input in my model. So no lengths, no diameters, no materials, sizes, or types, or anything. So here's my Excel spreadsheet. In my Excel spreadsheet, I have 258 rows of data that I'm going to import into the model. Okay, here's what all that information is. I am importing the nominal size for every single pipe. That's 1 inch, 2 inch, 3 inch, etc. I'm importing the nominal type, so schedule 40, And then I'm also importing the individual pipe lengths. So as you can see, these are all set equal to value. Now, here's the key thing to remember. If you want to import nominal sizes, the value that you use, 2-inch, for example, that has to match what is given in the property window. So if I open up this pipe, for example, and I want to use the steel material and import changes to steel, I have to make sure that my Excel spreadsheet, the text matches the text that's in these drop-down menus. So be aware of that. The next thing that I'm importing, and so what I'm going to do is I'm going to import the piping data to the base scenario. And when I import that data to the base scenario, it's going to propagate down to my 2 child scenarios as well. All right. The next thing that I'm importing is the controlled temperature. So I've got 2 cases, hot case and cold case. So I'm just keeping it simple here. I'm importing the heat exchanger's thermal model, cold, or the controlled outlet temperature, and my hot case is going to use 150 degrees Fahrenheit. Cold case uses 100, or it uses 50 degrees Fahrenheit. And as you can see here, I have my scenario path for base scenario / hot case, and then cool case. Now, how do you easily get the scenario path names? Well, you can see the scenario path name in the bottom left corner, but you don't want to have to type all that information out every single time. That would be a big headache. So instead, right-click anywhere in the scenario tree, and then you would say, you can either copy the scenario path name or the scenario path name with the file name, or you could save all of them to a text file. So I've already saved the full scenario path name to a text file. Let me open that up to show you what it looks like here. Let's see. There it is. Okay, so here's my scenario path text file. So I've got base scenario, hot case, cool case. All I needed to do was just copy that data and then paste it right into my spreadsheet. Super, super easy. The last piece of information I'm going to import is the tool names. Okay, in my model, as you can see, the valves are showing their name on the workspace, and it's just valve. So what I want to do is I want to import my valve tag numbers. So really it's just, these are my set A tools. So the name would be set A tool number 1, set A tool number 2, etc. And so what I did was I correlated my valve junction numbers, and then these are my tool number, or my tool names. So I'm going to import my junction name for all the valves. Now, after you get your Excel spreadsheet all set up, you have to go into your model and specify dummy parameters. So the key thing is we are not able, we don't import data to blank fields. So you have to set a value there that it also sets the units accordingly. So what I'm going to do is I'm going to go to Edit and then Global Pipe Edit, and I'm going to set dummy values for the nominal size, type, and length. So I've got steel, and then we'll just call it 1 inch to start. And then there's my type. Now, as you can see, I'm going to set them all to standard Schedule 40. They're going to come in as Schedule 40. And then for my length, I'm going to do 1 foot. So I put that information in there. Now I go to the model data. You can see that I've got dummy values. The next thing I need to do is I need to specify dummy values for my heat exchanger temperatures. Now I've already done that, okay, so I don't need to do it again. On the thermal data tab, I already did a global junction edit for all my heat exchangers to set them to use a controlled downstream temperature of 10 degrees Fahrenheit. Obviously, that's not the temperature that it's going to use, okay? Now, I'm not going to ever run my base scenario to get results there. That's just a thing to build my model. I'm only going to run my hot case and cold case. So I don't need to go back and change my temperatures in the base scenario. So now everything is ready to import. So to import, I'm going to go to File and then Import Excel Change Data. And then I select my workbook. And if you look in the bottom left corner, it's going to start importing those changes. So if you look at that, you can see how it's reading in all those rows of data. And it's bringing everything in. It does it really quickly. It modifies the individual scenarios appropriately. And very soon you'll be able to see the impact of what that looks like. So it's reading all that data. It's setting the data in the individual scenarios. And this is a summary that tells me all the changes that were made. I didn't have any issues. Perfect. So look at that. In my base scenario, I have my piping lengths, all my diameters, and my materials, sizes. Look at the type. Originally, I set them all to standard schedule 40. It changed them to just schedule 40. So it'll do that for you as well. As you can see, I now have my individual tool names. So I've got my set D tools, number 1, 2, 3, and 4. And if I go into my hot case scenario, I can right click on a heat exchanger. And I can see that my controlled downstream temperature is 150 degrees Fahrenheit. If I go into my cold case scenario, I can go in here and right click and that has my 50 degree Fahrenheit. So that's all there is to it. That's importing from Excel. And we will import Excel changes. And if you go to the help menu, contents and index, and then do a keyword search for import Excel, okay, for some reason my help file is not playing nicely with me today, but I guarantee you it's in there. Okay, so if you do a search for Excel, you'll find it. And I'll show you how to do the importing capabilities. Now, what I'm going to do is I'm going to use this same model for Excel exporting. Okay, so I have this whole system, and the Excel exporting capabilities are really nice because it allows you to dictate which important pieces of data that you would like to export. So let's do something. What I care about is what are the outlet temperatures at each of my valves as well as the pressures. Okay, so what I'm going to do is I'm going to create a group of the pipes that are immediately connected to all my valve tools, and I'm going to create those groups to easily modify my output control. And so what I'm going to do is I'm going to select these pipes right here, just like this. So I'm going in, I'm selecting all those pipes. I'm going to go to edit and then groups, and I'm going to create a new group. I'm going to call it tool pipes. I'm not going to select any of the junctions in there. Here's why I'm doing this is because my output control window, I don't want to show every single pipe in there. I just want to show my tool pipes there. So I'm going to go to show pipes and junctions, and then for I'm going to do none, and then for special out of 66 pipes, I'm only going to show those sets. So if I do if I do groups, I can select my group, select those pipes there, and then those are the only pipes I'm going to show results for. All right. So now what I'm going to do is I'm going to open up my Excel Export Manager. And the Excel Export Manager is what you use to export your data. So you go in here and you add a new row, and I can do a single value or a column of data or a row. Let's do a column. And it's going to be piping results. And what I'm going to do is I'm going to use, it's going to be temperature. So I scroll down here and I'm going to do temperature static outlet, degrees Fahrenheit. Pick a starting cell. So I want that to go into cell A1 first. This tells me where it ends, and the blue cells will give you an indicator of where that information is going into. Now, for some reason, that is not showing the appropriate pipe selections there. So, but essentially that's all that you would do is you just go into the new area and then add on your rows, and then maybe you want to do a single value, and perhaps this is your pipes, and then you want to put in temperatures. If you only care about one specific parameter, then you can specify that exact object. If you click on the show example, this will show you what it's going to look like when it goes into Excel. And so you'll probably need to use that fairly often to see how it's going to look. And then if I uncheck this box, you can see how that's different. So use that box and it'll show you what it's going to look like when things get exported. Okay, so if I do other, or if I do table, I can put all my entire pipe results in there. Now let's do something else. What I'm going to do is I'm going to run my base scenario. And I'm not doing this really to get any actual results. I'm just running it to create a graph. Okay, well that didn't work. The reason why is because I'm using 10 degrees Fahrenheit for the heat exchanger outlet temperatures, and so it's probably liquefying some of that gas. So let me use the hot case instead. And so I run the model here. Okay. Let me open up a more simplified example here. I must have changed something accidentally in that model, and it's not exporting properly. Let me use this guy, natural gas burner. All right, so what I'm going to do is I'm going to run my English unit scenario, and I'm going to create a graph list item. And the way that I'm going to do that is I'm going to go to model data, workspace. I'm going to select the pipes in this flow path, and then for my graph results, I've got them selected there. So I'm going to show pressure in terms of PSIA and temperature in degrees Fahrenheit. So I got pressure and temperature. I'm going to follow this away, P and T versus L. Here's why I'm doing this, is because when I go back to my Excel Export Manager, one thing I want to export is column data for piping, and let's look at the friction factor. Okay, so I'm going to export the friction factor for that, and then I'll do another column of data. Now I'm not showing friction factor in my output control. So if I go into my output control window here, you can see that friction factor is not in that list of displayed parameters. This is the other reason why the Excel export is useful, because you don't have to show every parameter on the sun just to be able to export it. So when I go back into my Excel export manager, I'm going to do another column of data, and I'll do enthalpy loss. And we'll put this in cell number C1. And as you can see, it'll automatically figure out the ending cell that you need to have. And then I'll do one more. I'll do table this time, and I'm going to do valve summary. And so this will give me my valve summary, and we'll put that in cell F1. And then the last thing I'm going to do is I'm going to do that graph list item. So if you create a graph list item like how I did, you can choose graph, and then it's my profile plot right there, and then you specify which cell that you want to put it into. And so we'll do say F15. That'll be my starting cell, and I'm going to use it to create a new workbook. Now, if you did a batch run of multiple scenarios, you can export multiple scenarios of data into multiple Excel spreadsheets. I'm just going to do this one scenario right here. So I run my model to get results, and then once I get results, I'm going to export that data. So I go in and I'm going to export the data. It's setting up the Excel spreadsheet. And here's my spreadsheet. This just tells you what happened and gives you a summary of if it was successful or not. And then here you go. This is my data. And so I've got my piping friction factors, my piping enthalpy losses. I've got my valve summary table right here at the top, and I've got my profile graphs. And since I only did one scenario, I only put it into this one scenario. If I ran multiple scenarios, it put it into multiple ones. So that's what you can do for the Excel Export Manager. Again, that tips and tricks blog page is incredibly useful. And so if you go into the blog page right here, and I believe it's it's page number 1, you're going to find a blog article that Scott Lang wrote a couple months ago on how to use the Excel Export Manager. So you can find that right here. This is a very useful article. It was written in terms of Fathom 10, but the concept and the process applies directly to Arrow 7 as well. So even if you don't have Fathom, read this article and it'll show you how to use that Excel Export Manager, and it'll give you some more ideas. Okay, last but not least, model importing. And so I apologize, I'm just a couple minutes over. Bear with me, this is the last thing that we're gonna go through in the webinar today, so hang in there, and we're almost done. And so I want to import a piping component file from a AutoCAD drawing, perhaps. So in order to do that, you go to File, and then I'm going to import a piping layout. Again, your options are piping component files, Caesar2, GIS, EPANet. So I'm going to do PCF. Now, right here on the right-hand side, my quick access panel changed. This is where you have a lot of flexibility on and control on how you import what gets into your model. So the first thing you have to do is go to this little button right here, and you have to find your folder where you have saved your piping component files. So I have that folder right here, and I've got 2 of them. So if you click on one of them, it's going to bring up a paste preview mode. So this is PCF import number 1 file. This is PCF import number 2 file. Okay. You can import multiple PCF files into the same workspace. And so that gives you a lot of flexibility there. Now, after you select a specific file to import, below that, it will tell you what the PCF object is and what the associated AFT object will be, okay? So it's going to bring in your elbows and your area, so you got a reducer here. It's going to bring that in as an area change. And elbow is going to come in as a bend junction. Now we've got a few valves in here. Let's say that this valve is not a regular valve. It's actually supposed to be a control valve. This is where you can go into the drop-down menus and change what type of junction that's actually supposed to be, okay? So that's where you can dictate what types of junctions get brought in properly. If you select any of these objects and click on the property window, this will give you information that is contained within the piping component file about that particular object. Now, the majority of that information doesn't mean anything for a flow model, but it will come in for you if you want. So you can look at what that information is right there. Also, if you want to actually include that information in your model file, you can click on this option down here to import the data to your pipe or junction notes field. All right, so that's where you can import that property information there. The next thing is maybe you want to import various elbows as pipes and lump them in. You can toggle this option on and off. That way it may not bring in all those individual elbow junctions and short pipes if you don't want. There's a scaling factor that we come up with. You can change that if you want. You can choose if you want to ignore pipes that are shorter than a certain length. The next maintenance release of Arrow 7 that you're going to see will give you an option that you can ignore pipes less than a certain diameter as well. So if you've got very small diameter pipes that you don't care about, you can neglect those. So again, another very important reason why it's really important to stay up to date with the latest releases. Last but not least, this troubleshooting button is helpful. If you run into an issue importing your model for PCF, or if you have ideas or suggestions, click on that troubleshooting button and let us know, and that way we can make those updates appropriately. So now I'm ready to import. So when I click on import, it's going to lay out the model for you. And it does it in a very beautiful fashion, very quickly. And so that saved me tons of time. Now I don't have to keep going to the toolbox and dragging and dropping a whole bunch of junctions on there. Let's go ahead and import in the other one as well. So I'm going to bring this guy over here to the side, just like that. And I'm going to import my elbows as elbow junctions. So it's bringing all that information in there. And it doesn't take too long. So there you go. The system is already built. Right now, once you're done, you would click on Close. And then if I go to the model data window, look at this. It's bringing in your length data, your diameter data, and then in the current maintenance release of Arrow 7, it's not doing elevation for the junctions yet. Fathom it is. As you saw when I mentioned earlier, Fathom latest release was August 20th. The latest Arrow release was August 6th, okay? So the August 20th release in Fathom, that's where we introduced the ability where it will bring in your elevation data for your junctions, okay? The next maintenance release of Arrow will also bring in your elevation data for junctions. So keep an eye out for that, and that way it'll bring in more information for you. If you wanted to import a file from a Caesar 2 neutral file, process is exactly the same. GIS and EPANet, it's similar. And so that's how you can do model importing, and it'll save you tons of time, and that way it'll build the model of your system for you. It's one of my favorite new features, and I can't wait for you all to start using it. So play with it, break it, see how it works, and let us know your feedback on how we can make it better. Okay, well, that is all that I have for today. Thank you all very much for your time. And again, if you have any questions, you can email me, at benkeiser@aft.com. That's BENKEISER@aft.com. You can email our tech support team. They're awesome. They'll do a fantastic job at helping you with your questions, and we'll get you guys all taken care of. So thank you again very much for your time, and have a wonderful day.